Okay, so coming back from that last video, you should have gotten to this formula, the formula for the sum of an arithmetic series. So the nice British gentleman kind of showed how you can kind of do some clever kind of manipulations to get this formula. Now this is totally true. We're going to manipulate this just a little bit to make it a little bit easier to use, and I think that will kind of help. Okay, so we're going to go one step further, and then we're going to practice using this formula. So first off, he calls the first term A, and we called it A1. So just to kind of be consistent here, if we're talking about our stuff, this is A1. Okay, so I want to change this up a little bit, and I want to go n over 2 times. Now I'm going to rewrite this to A1 as A1 plus A1. Okay, you'll see why in a minute. And then I have the plus n minus 1 d. Okay, now this stuff should look familiar, some of this. Okay, let's talk about what these pieces mean. So S stands for sum, right? Because we're adding up. In the series, we're adding up all these different pieces. So we want a sum. This is the number of terms that we're adding up. Okay. Then we're going to kind of skip over this because we rewrote it right here. N is, again, just the number of terms that you're adding up. 2 is the regular 2. But what is A1? Remember that A1 was our first term. Okay, now this should look very familiar. A1 plus n minus 1 times d. First term plus the common difference, n minus 1 times. This is the explicit formula that we talked about. And this piece of the explicit formula will give you a of n, right? The explicit formula is a of n equals this. In other words, whatever term you're on, or the last term in the sequence, if you want a certain term in the sequence. So this represents the last term, right? Because if we have n terms, then a of n is the number in the last position. Okay, so I can rewrite this formula. Let's come down here. S of n equals n over 2 times the first term plus the last term. Okay, that's much, much easier to use. Now in your book, they write it something like this. N times, they say T1 plus Tn over 2. Okay, same formula, right? N divide by 2, they put it on the inside. It's all right, this is just kind of a distribution idea, no worries there, it's the same thing. And then T1 stands for the first term and Tn stands for the last term. Okay, so this is probably the version that I would look at, but we use A's. I don't know, I think that's more common. Like, I've seen it written with A's more often than T's, but just kind of connect it to what's in your book. Okay. This is the formula for the sum of n terms in a sequence or series. Okay, that's the one you want to use. Now, let's go back and revisit one of the problems we just did. So we did 15 on your homework. This is 15. Okay, so it gives you a sequence. We write it as a series. We add all the terms, we get 91. Let's see if we can use this formula to make our lives a little bit easier. Okay, so Sn, the sum of however many terms we have, in this case 1, 2, 3, 4, 5, 6, 7. The sum of these 7 terms is equal to 7 times the first term, 7, plus the last term, 19, divided by 2. Okay, so this is 7 times 26 over 2. All right, 7 plus 9 is 26, which is 7 times 13, because 26 over 2 is 13, which is equals 91. Okay, so it works. Okay, that's the sum formula that we're going to use. So let's go back to the worksheet we were on, and let's use this new formula. Okay, so here's the formula we're going to use. Sn equals n times a1 plus an over 2. Okay? First term, last term, number of terms. Okay? So the sum here, Sn, is equal to n, the number of terms, 16, sweet, times a1, awesome, that's 30, plus the last term, okay. So now we're a little bit stuck. And we're stuck because we don't know the last term. This dot, dot, dot means this sequence keeps on going until the 16th term. This is just 1, 2, 3, 4. We need the 16th term. Okay? And then over 2. So once we have that last term, we can put it there and we're good to go. So we have to kind of write out the formula. Then we got to figure out, well, what is a of 16? What is the 16th term? Well, it's the first term, 30, plus the common difference, which is 8, times n minus 1. Right? At the 16th term, we'll have added 8 to 30 15 times. So this is what is going to give us the last term. Now this right here is using our explicit formula. Right? So no worries, we can do that. So let's figure out what that last term is. So we're going to do 30 plus 15 times 8. Now order of operations, our calculator is going to know to multiply these first before they add, because that's PEMDAS. So we're good there. So 150 is the last term, the 16th term. Okay. So now I have the piece that I need to finish the formula. Okay, so I just got the last term, but I don't want the last term. I want the sum of all the terms. I don't want to know that there's the last number is 150. I want to know what's 30 plus 38 plus 46 plus 54 all the way up to 150. Okay, so let's do that. So let's do 30 plus 150. Okay, cool. That's 180. We're going to divide that by 2. That's 90. We're going to multiply that by 16. Okay, so the sum here is 1,440, which is a lot less work than having to figure out what all the terms are and then add them all together. Okay, let's do another one. Let's do 19. Okay, so there's 14 terms, okay? Now we know the sum of the 14 terms is going to be equal to the number of terms, which is 14, times the first term, which is negative 24, plus the last term, which we don't know. This isn't the last term, it's the fourth one. The last term is the 14th one. So we got to figure out what that is. And then we're going to divide by 2. So whenever we figure out what a of 14 is, we put it right here. So we got to do one more step. And for this, we're going to use our explicit formula. Okay, so a14 equals the first term, minus 24, negative 24, plus n minus 1 be 13, right? 14 is n, so n minus 1 would be 13, times the common difference. And if we're going negative 24, negative 28, negative 32, we're going down by 4 every time. So negative 24. So this will give us the last number, the 14th term. Okay. So we got negative 24 plus 13 times negative 4. So it's negative 76. That's not our answer. That's just the 14th term, the last term. Okay, that goes right here. So now we have our last term. We can put it all together. Negative 24 plus negative 76. Negative 100 divided by 2, negative 50 times by 14. So our sum is negative 700. Okay? So that's how you use the formula. Now, if you look at the formula that we got from that British guy, his has like the explicit formula in it as a piece of it, because sometimes you don't know the last term. So the way that he wrote it makes a lot of sense if you don't know the last term, because you can just, as long as you have the first term, the number of terms, and the common difference, you can get there. So this formula that he gave us is kind of nice because it doesn't require us to know the last term. But what we're doing is we're kind of breaking it down into pieces so it's easy to understand. So we're using this formula. We're saying, okay, hey, this is your formula if you know the last term. If you don't know the last term, then go back and use your explicit formula, which you already know. And if you put those, if you put the explicit formula in here, you get this. which is the same as this. So either way, you're using the same formula, but I think it's a little bit easier to visualize what this means, and then be like, okay, if I don't know an, I know how to find it. So you might, think about it differently, but that's, I think, the easiest way to think about it. Okay, we've got a couple more to do, so let's look at the next problem set. Okay, now the issue here, well, let's just go through it. Let's set it up. So we want a sum, right? We want the sum of some terms. How many terms are there? 1, 2, 3, 4, and then a bunch in the middle that we don't know. Okay, so we don't know how many terms there are. So that's the problem here. S of n is equal to n. I have no idea what those are. I don't know how many terms there are. I do know the first term, though, and I do know the last term. Awesome. So in this case, the only thing that I need is n. I just need to know how many terms are in the sequence, right? So we got to remember, well, how do we do that? 13 and 14 are examples of how you find the number of terms in a sequence. Once you have the number of terms in the sequence, or in the series in this case, which is the same thing, then we can figure out what the sum is. So we have to figure out, we have to kind of think of this as a sequence first, find a number of terms, and then we can add them all up, where we can use our sum formula. Okay. So let's think of it this way. What's the jump? What are we going up? Like, what's the overall increase? Okay. So we got 96 minus 19. Okay, so we're going up by 77 overall. Okay. But we're doing it in increments of 7, right? Plus 7, plus 7, plus 7, etc. So we got to go, okay, I'm going up by 77 in total in increments of 7, which means there's 11 jumps. I've added 7 11 times. 1, 2, 3, 4, at the very end, at the last term. Okay. If I've added 7 11 times, so this is 11 increases. That means this is the 12th term because we don't increase on the first one. Okay, so we add 1 to that number, and we get the number of terms. Okay, so there's 12 terms in this. So that means the sum of 12 terms is 12 times 19 plus 96 over 2. So we basically had to solve for n. So in these 4 problems, you have to find the last term using your explicit formula, and then you can use your sum formula. In this case, in these next 4 problems, you know the last term. You got to go find out what n is. Okay, when you find out how many terms are in the sequence, then you can plug it all in. Okay, so you got 12 times 19 plus, actually let's do this a piece at a time. 19 plus 96, cool, divided by 2 equals, okay, 57.5. Seems kind of weird because that's a decimal, right? But we're going to multiply this by an even number, and we're going to get 690. Okay, that's the sum. Okay. Okay, so you got 3 more of those to do. Set up your formula, right? Sn equals n times 12 plus 60 over 2, and you just got to find n. So figure out, how much are you going up? We're going up by 48. How much are you going? What's the increment that you're going up by? Plus 6 plus 6 plus 6. So 48 divided by 6. You're going to add 1 to that number, and that's n. Okay, so you got to know how to do 13 and 14 before you can do 20, 21, and 22. And then 23 and 24 are really similar. Okay. Okay. Last example. Okay. This is very, very similar, but it's a different notation. Okay, this is called sigma notation. This is the Greek letter sigma. Okay, and it means sum. It's basically an S, but in Greek for sum. Okay, so sigma means sum. This right here is your starting point. So n equals 1 is just saying start at n, or start at 1. Start at the first term. Okay, so this is the start. This guy right here is the stop. It tells you how many terms are in the sequence. So stop at 6. So start at the first term, stop at the 6th term. Okay, and this right here is your explicit formula. So there's multiple ways to do this. I'm going to show you the kind of the long way, and then I'm going to show you a shorter way to do it. Because with like 6 terms, it's pretty easy. With 8 terms, it's pretty easy. With 35 terms, yikes. You're going to have a tough time with that one if you do it by hand. So let's talk about what this looks like. So what these pieces mean is start at 1, okay, 1, and then stop at 6. So I have term 1, 2, 3, 4, 5, 6. Okay? This will tell you what the number is in each term. Okay? So 6 times 6, or 6 minus 6 times 1, 6 minus 6 times 2, 6 minus 6 times 3. I'm just plugging in that number n here for each term number. So if n is 1, that's my first term. Cool, that's where I start. I plug it in, and I get 6 minus 6, which is 0. 6 minus 12 is negative 6. 6 minus 18 is negative 12. All right, if I plug in a 4, I have 6 minus 24. So you can see the pattern, right? Subtracting 6 every single time. Okay, so those are my terms. Now, since this is a sigma, that means sum them all up, add them all together. So the sigma means you have a series. So this tells you how to fill in your series. Okay, so we can just add all these up. 0 plus negative 6 plus negative 12 plus negative 18 plus negative 24 plus negative 30, right? We get negative 90. Okay. Is there an easier way to do it? Of course. We can use our sum formula, right? So we know Sn is equal to n times a1 plus an over 2. Okay, so the same idea. So the sum of 6 terms is equal to 6. Okay, now all we need to do is find out the first term and the last term. So what we could do is say, well, the first term is 0, the last term is negative 30, and I divide by 2. So 0 plus negative 30 is negative 30, divided by 2 is negative 15, times by 6. Negative 90. So either way, okay? So this is what the notation means, and you can write it all out, but we don't need to do that every time. So let's try to save some time on this one, okay? So sigma means sum. This means the first term is 1. This means the last term is 8. So this is telling you n equals 8, right? I know this says n equals 1, but this is like n equals 1 is the starting position, 8 is the ending position. So this is how many terms there are total. This is just telling you where to start. Okay, so the sum of 8 terms, because there's 8 of them, is going to be 8. And then we just need first term, last term over 2. So how we find that is we just plug in the number. So the first term is going to be A1, and the last term is going to be A8. Okay, so for the first term, plug that in here. That's 9 minus 5 times 1. 9 minus 5. Okay, for the 8th term, it's going to be 9 minus 5 times 8, or 9 minus 40. Okay, 9 minus 40 would be negative 39. Sorry, negative 31. Okay, and that's that term. So the first term is 4. The last term is negative 31. We're just using this formula to figure out, what our first term and our last term is. You could fill in all the other ones, right? 2, 3, 4, 5. Like if you wanted to, you could go fill all those in, plug these all in like we did over here. But you don't need to because we really only need the first and last one, and then we can put them in the sum formula. Okay, so let's finish it up. We got 4 plus negative 31 or minus 31 divided by 2. Okay, and then we're going to multiply that by 8. Okay, so without finding all of the individual, terms for this series, we can still get it because we can use our formula. Okay, but I just wanted to show you, kind of what's going on. So again, this is where your first term should start. Starts at 1, they all start at 1, so that's not that big of a deal. This tells you how many terms there are, so this is important. How many terms are there in the series? There's 8. Okay, that's important because that goes here. This formula here tells you what the terms are. So plug in 1 for your first term, and you get 4. Plug in 8 for your 8th term, and you get negative 31. And then you have the A1 and the AN that you need to figure this out. So this is kind of like your explicit formula, just simplified. It's AN equals 9 minus 5N. So you plug in, right, A1 equals 4, AA equals negative 31. And then you put those here. Okay. So you got 2 more. Now this one, you don't want to do by hand, right? Because 35 is a pretty big number. So all you got to do is find out how many terms you are. There's 35. Okay. So the sum of 35 terms is 35 times first term, last term over 2. So plug in a 1 here. That will be 3 times 1 minus 13. So 3 minus 13. Okay. How do you get the last term? You plug in a 35. So 35 times 3 minus 13. Whatever that number is goes right here, and then you're set. Okay, so that should get you through most of it, and you can go back and do this one on your own. All right, hope that helps, and I know that's kind of a long one, but most of the videos were review, so hopefully you didn't spend too much time, but I'm going to give you a couple days to get this one in. So thanks for watching.